Hi there, I'm Dennis Mulder, the VP of Customer Success of Volumes. In this video series, we're going to explore our technologies and learn how to make use of them. Let's get going. The compute in cloud computing has already been standardized. Linux is a standard operating system in modern environments, and Kubernetes is a standard orchestration layer used in modern applications in most clouds. This enables application teams to write their applications much faster, and it enables the DevOps teams to deploy the same application in multiple locations. But when it comes to data, things are still siloed. Customers have to understand each storage service of the cloud provider they choose. Often, they're struggling with data bottlenecks, unpredictable performance, resiliency issues, and reliability issues. Volumes is bringing the same approach of cloud computing and Kubernetes to data infrastructure. We use Linux as the open standard data path, and Volumes does the orchestration on top of that. Volumes is creating a direct path between the application and the underlying storage media. This guarantees that you get consistent performance without a noisy neighbor effect. You don't need to be a storage expert to get the best result. You just define a declarative policy of what your application needs. In order to explain you our cloud-aware data infrastructure, I prepared this slide. On the left top, you see the green cloud, which indicates our Volumes data infrastructure composition service. This is a SaaS portal as well as an API that you can use to declaratively define what the needs are of your application. At the bottom, you see 4 servers with 4 NVMe drives. Typically, we use the Azure LS series or the AWS IXI series to offer you the high performance that you need. These drives have what's called ephemeral storage. They're locally attached, so you will have to provide the resiliency yourself. As soon as you assign those drives to Volumes, what we will do is we'll media profile those drives. In the L8 SV3s in Azure, you'll typically find that 4 of these drives combined can provide 800,000 IOPS at 3.2 gigabyte per second with sub-millisecond latency. The capacity is typically 4 times 1.8 terabytes, so that gives you a 3.6 terabyte of space, assuming we apply RAID 1, which would be the minimum, I would say. So what we need next is, if you provision, say, your MySQL on top, we need a small stack. This is the Volumes connector service, and the connector service is used to talk to the SaaS data infrastructure composition service to allocate the space required for your application and align with the policy that you define. So suppose we want a 1 terabyte database that is spread across 3 nodes in 2 different zones. By the way, we also support 3 zones if you like. Then this way we would have that space allocated. After that, Volumes is out of the picture, as in we've configured Linux such that the resiliency and other capabilities are baked in. Into your Linux data path, basically. So we step out of the way. We obviously do monitor, which is visible in the SaaS portal, but we are not in the data path. Unlike many other solutions that have a controller architecture, we don't have a controller architecture. We're native Linux. We rely deeply on kernel capabilities in the Linux stack. So there's still space left, right? We allocated 1 terabyte and 3.6 terabyte is on the drives, and hopefully we didn't assign all the IOPS and all the bandwidth to this one workload. So what we can also do is kind of pool workloads on top of the same storage without noisy neighbor effects because of the way we define our policies. So suppose I have another PostgreSQL environment that needs to be spread across 2 nodes, across 2 zones, then I can do that. Now you may wonder, what if something fails, right? In Azure and AWS, hardware fails, they assume failure. So if, for example, the second machine fails, indicated by this animation, then what we will be able to do is replicate the data of the other copies to the fourth machine in the other zone in order to make your workload still as resilient as you had defined in your policy. So now you may wonder, what is this whole Linux data path story? Basically, what we do is we detect the capabilities that the VM types have and optimize what we can do. So for example, if it's an InfiniBand enabled VM, like an H series in Azure, for example, then we will actually use that InfiniBand capability to provide higher bandwidth or higher throughput capabilities. So with that, I hope I provided you with a big picture overview of our cloud-aware data infrastructure. I look forward to meeting you again in the next videos.